top layer of the water can have a different reading than what the pool is. Okay. So I rinse it first. Get all the stuff out from the last pool you tested. Flip it upside down, right side up. Okay, and then I look at the lines. It'll tell you which ones you need. But for pH and chlorine, it's on the top. Okay, so now I'm at 44 and 9. Okay. Our 5 drops. Chlorine is R1, 5 drops, and R2, 5 drops. Put your cap on, flip it up and down a couple times, and then make your reading. Okay, it's just a color match. pH is on point. 7.4 is your neutral. Anywhere from 7.4, 7.6, even 7.2 is good. Okay, that's where you want to be. If your pH was really high, let's say it was 8 or higher, you don't know if it's 8, you don't know if it's 14. Okay, scale is from 0 to 14. We're only reading from 7 to 8, but the pH can go up to 14, but you don't know if it is without doing the other two. So you have 2 more. One's a base demand, and the other one's an acid demand. If your pH was really high, you need acid demand. If your pH is really low, you need base demand. So you drop one at a time and you count the drops until that changes to the neutral color that you want. Because pH really high is going to be a really dark magenta color. And you go 1, mix, 2, 3, mix, until you get the color that you want. And it's going to change the color, and you count however many drops it takes to get where you want. Okay, 5 drops. Now I'm at 7. So 5 drops, if I wanted to drop this pool from 7.4 to 7, I have 5 drops of acid demand. There's other calculations, but here in the back of the book, you have tables. To decrease pH using dry acid, to decrease pH using muriatic acid. I had 5 drops in 20,000 gallons is 2.86 quarts. If you don't know how many quarts are in a gallon, there is another chart up here somewhere. Might be in the back somewhere, but there's another chart of how many quarts are in a gallon. If not, we all have phones and you can ask Google how many quarts in a gallon. Well, there's 4 quarts in a gallon. Okay, well, it's 2.86. I'm going to need 3/4 of this gallon. If we were really doing this right, we would have measuring cups and measure out the quart and put it in. We're not going to try to guess, oh, I think I have a half a gallon. Put it in there. Well, you're short because you only put 2 quarts, not 2.86. So it's never going to reach where you are desired to bring it to. Chlorine, 0 chlorine, right? We put 5 drops and 5 drops. There's no color. There's no chlorine in this pool. Now we're going to test for fruit or total. Can't remember. So you put 5 more. 1, 2, 3, 4, 5. This, you do not want it to change color. If you do, you have to remember your difference in color. So look, it changed color. We don't want this one to change color because now it's telling me it's got bad chlorine. Okay? It went from a clear to a pink, and it's about a 1. And you do that You correct that through super shocking. It's called a breakpoint chlorination. Okay? You reach a certain point in chlorination that it breakpoints its lock. It's got a lock on it now because you've got bad chlorine. Bad chlorine overpowers good chlorine. Okay? Total chlorine versus free chlorine. Don't dump your reagents into the pool. You don't.
Say that again?
I don't dump it back in the pool. It's free chlorine versus your total chlorine. They should equal each other. If there's a difference, I think they should equal each other. If there's a difference, then you have bad chlorine in the water, and you correct it by super shock. I don't like dumping it back in. Some of these, if you drop it on your skin, it says to be careful not to, you know, it's corrosive. I think they even have it on the bottle. There's one of these that, you know, say don't, you know, it's corrosive. Better make your children. Now, will 5 drops really make a difference in 27,000 gallons? Probably not, but I don't like tossing it back in there. So you rinse it out. The green and blue. Green is total alkalinity. Green or red. Green, red.
Green is total alk, blue is what?
Green is total alk, blue is calcium. And you want it at the 25. Okay, so 25 mil. Both of them are pretty similar. 5 drops for the first one. This one is 2 drops, and then you count your drops. 5 drops, 20 drops, then count. So we'll do alkalinity. 1, 2, 3, 4, 5. Mix. 2. It's going to change from green to red, and I'm going to count however many drops. 6, 7, 8, 9, 10. About 12. Each drop represents 10 parts per million. 12 drops times 10, 120 parts per million. Okay? That's within range. 100 to 120. On a salt pool, I like to look at it around 80 to 90 on a salt pool.
So if your alkalinity is high, how do you get it to go down?
Couple different chemicals, and it'll tell you here you can do it with.
Oh, it tells you.
Decrease alkalinity using dry acid, decrease alkalinity using muriatic acid. Okay, so there's 2 different chemicals you can use.
So if I test that pool and it's already high in acid, and I got one to get the alkalinity down, am I going to add more acid to it?
No.
Yeah, no. It's concrete.
It'll naturally come down. If your acid is high, if your pH is low, which is acidic,
yeah.
and your alkalinity is high, then it
will balance it.
It should, yeah. But the first part is getting an accurate reading. The second part is an accurate measuring of your chemicals. Why are you going to go through this trouble in knowing what's in the water?
That's what I was curious.
And then not accurately put in what it's needed?
Yeah. We
So,
don't have any measuring cups.
huh?
I was like, we ain't got no measuring cups running around here.
There are no measuring cups. Right.
So is this, are we wanting to do this still?
If you want clear pools, yeah.
Yeah, I want to
And
clear
you don't
pool.
want to have to go back
And keep messing with it.
and keep messing with it. Oh, why is it still cloudy? Why is it still cloudy? Well, because when you tested it, you might have not put enough or put too much, or nobody knows what's in the water. to know?
Another one is that so if I don't have measuring stuff and I don't have what I need to know exactly what I'm putting in there, and we're just gonna wait.
If you don't have what is needed to put in there, then you need to go get it, put it in. I wouldn't put anything in there that...
Without measuring it is what I mean. We don't have anything to measure anything.
Right.
That's what I'm saying. And if you want me to put exact stuff in there, which I'm fine with, and I'm fine with getting an exact reading, but is there a point if I don't have the stuff I need? Like the measuring stuff, to be able to measure how much I'm dumping in. So.
Well, you just get a simple measuring cup. Measuring cup. You've got to get one that does...
I have one of pounds.
Measures pounds, and you... Well, not pounds, but volume of water. Like,
or just like what comes in our chlorine buckets, like that measuring cup.
No, that's too small.
Yeah.
You can use it. I've used it before when I'm in a pinch. You can... That scoop is half a pound of chlorine.
I'll dumping any acid in it or whatever, and then like you said, oh, I think I got a half a bucket here, or I think I put 2 liters in here. If we're going to be using this, and we're going to be using this accurately, I want to be able to put accurate stuff back into it.
And chlorine.
You're wrong.
You already tested it?
120.
For what?
Total out is 120. Did you use the test strip?
Nope, I'm just guessing. As far as laughing.
This is salt.
Straight from the test strip.
1 drop of this turns it yellow. Then you count these drops till it turns salmon. 8 drops.
And then you drink it?
Really chunky.
Yeah.
No
Has
thanks.
silver in it.
What the
Want some
heck?
silver? Yep, this is a silver nitrate.
So they used to make old film
What's it supposed
For,
to be? Salt. It's 8.
cameras and
That's
stuff.
8. 1 drop represents 10 or 100, sorry. So there's 800 salt
Parts per
million.
So it's got to be.
It needs to be 3,000.
So it's real low.
Yeah, so there's 800. I know that there's 800. Instead of knowing, oh, the salt's low or the salt's high, I know close enough that it's 800. Now it can be between maybe 750 and 850, but still that's pretty accurate without having to go with a digital thing that's going to
So
go
how many
down
bags
to
of salt raise it 1 part?
1 bag, 480 for 10,000 gallons. So if you have a 27,000 gallon pool, you'll need 3 bags to raise it about 350.
And how do you know that?
It's on the bag.
Yeah, but how do you have it memorized?
Well, I mean,
They
not
ran
really.
this company for
Been
years.
doing it for 25 years.
So,
That's why this is the bread and butter.
salt.
So it needs 3 bags.
You need 3 bags will raise it 480.
Oh, 3 bags raise it 4. I thought you said 1 bag.
In 30,000 gallons,
There's only 20.
so 10,000 gallons, it'll raise, 1 bag will raise it 480.
Oh,
This
so
one
you
has
need 2
about
bags.
27,000.
Okay, 6 bags.
I just go to 3,000 or 30,000 for this pool.
Oh, it's not 30,000.
No, it's 27.
No, it's. I don't think it's that
It's
much.
18 by 36.
Oh, I figure it's like 25,000.
Okay, that brings up our next. How many gallons do you know is in the pool? Because you need to know how many gallons. After you get an accurate test, you need to know how many gallons are in the pool, right? You could probably ask Google.
And Google say average. It'll take the 8 feet by 4 feet average, and it'll average it out.
There's a formula. You think you take the length times the width times your average depth times a constant number. Rectangles, it's 7.2 or something,
Oh.
7 point something, I can't remember. Ovals, it's different because you have less pool, so it's like 6.8. Okay, so I can find my calculator. 18 times 36 times your average depth. Average depth is 8 feet. Well, not average depth is not your 8 feet, but you take 8 feet to 3 feet. Okay, 8 plus 3 is 11, and then you average that out in the middle, or you divide it in half, so 4.5.
5.5.
5.5, right?
5.5.
Trying to talk and think, and it doesn't work for me. So 18 times 36 times 5.5 times your constant 7.5. I have to look that up, but 26,730 gallons. Okay, so close to 27,000. So now you know how many gallons are in the pool versus what your test is reading to know how much chemical to put in the pool. If you have a sun ledge, it's an L shaped with a sun ledge, you've got to make a separate calculation. If it's a 10 by 10, length times width, your average depth, 1.5 feet, so 1.5, your constant, 7.5, and that'll give you the gallons of that little sun ledge. Then you times it to, or add it to your pool. Like Dufresne. Dufresne has an 18 by 36, but they also have an 8-foot sun ledge. So you actually go 18 by 26, get that measurement, then you do an 18 by 10 for the little side, and it's going to be less. It's going to be more like a 25,000 gallon pool.
Just add the two together.
Add the two together, then you can go in here and you say, okay, I've got 5 drops of this, and it goes across. I had 5 drops, then you go across 20,000 gallons. I need 2.8 quarts plus another 1.4 quarts and pints, plus another 4.5 fluid ounces. So you've got to know your fluid ounces versus pints and versus quarts and gallons. Okay, and there's a chart somewhere in here that tells you somewhere. All right.
Calcium's a pound per 10,000. Total ounce a pound and a half per 10,000.
I think Jesse made up a
Cheat sheet.
troubleshooting sheet. It says cloudy water, what's the causes, what's the solution. And then this book will tell you too. It'll tell you pretty much everything that you need. Any questions or whatever. How do I know what's going on? How do I troubleshoot? How do I reach a breakpoint chlorination? Okay. How does temperature change your chemistry? Because what you want to achieve is that the pool is neutral. It's neither corrosive or alkaline. Okay. Either direction it's in, it's bad for the pool equipment and shell and bathers. Okay, so you can have, what you want is you want a range in your neutral range, and if you're within that range, then the pool is non-corrosive or alkaline and it's safe to swim in. You can have a really high calcium that's still in range of your calcium, because calcium can go to 500 to, I don't know, 800 or whatever. If you're on 800 calcium, it's still within range, but some of the other things need to be adjusted. And also temperature. Temperature has a big part. Right now, if this water's 70 degrees, the chemistry in 70-degree water is going to make this either corrosive or alkaline versus a pool that's 95. When you're testing spas, it's a little bit different because it's smaller amount of water and it's higher temperature, so it's a little bit more tricky. And your bather load, you get 4 or 5 people in a hot tub. That's a lot different than you get 4 or 5 people in a pool. Okay, and you're increasing your temperature, you're increasing the bather load, and it's harder to measure because now you're using teaspoons of chemicals in a hot tub versus pounds, quarts, or whatever. Any questions?
Is there a written test?
Huh? There will be an exam tomorrow at the end of the day.
Doug's lost.
Like, what is everybody doing?
So if you have questions, like my pool's cloudy, I'm going to ask you, what's your test reading? What are you testing? Because there's 3 things you need. You need circulation, okay? Is the water moving? Okay, you can have perfect chemistry in this pool, but if this pool does not move, it will grow algae quick. And once the sun hits that algae, it'll grow quick. So you need circulation. Is the pump working? Are there leaks? Are there bubbles in the pump? Are the skimmers pulling in water? Are your returns pushing water in the direction it needs to be? Okay, you might have to put an eyeball on a return to change the degree of where the water's moving. If it's coming up to the surface, you know, you're losing a lot of that water movement to the surface instead of getting into the pool. So if you're like, oh man, I've got algae growing down here, there must not be enough water circulation. Second is filtration. Is your filter clean? Is it filtering the water? Does it need to be backwashed? Do the cartridges need to be cleaned? Do you need a new filter, new sand, new cartridges? Okay. And then the third one is your chemistry. So if you have those 3 in check, you go through that checklist: filtration, circulation, and chemistry, then your pool will be clean. I have had pools in the summer where we're just in the routine of going, checking everything, testing it, cleaning it, right, and leaving. And then the next week it's green, and we're like, what's going on? Everything was perfect last week. Well, the filter was dirty, and it cut down on my circulation, and it wasn't filtering because the filter was dirty. Once we cleaned the filter, it was a DE filter, we took it apart, cleaned it, put new DE powder in it. It took off and was fine for the rest of the summer. So don't overlook, you know, oh, the pump's pumping really good. Oh, the pressure gauge is reading good pressure. I wouldn't rely on it. If you have a problem with the pool and the pressure gauge is reading normal and everything looks normal, your test reading is normal, look into that filter. One of those pleats could be ripped, and now the water's just not even going through the filter, it's just right through, you know. We're not a service company. I'm not expecting everybody to like be a pro at balancing pool water and making crystal clear water overnight. But we do need, when we build these pools, especially the ones that sit over the winter where nobody's taking care of it, we're trying to troubleshoot them now, we know what we're doing. Because usually when we build the pool and put water in it, we can hand it right over to them, right? But here in the spring, let's try to get our accurate measurements, accurate readings.
Should I just take flock and so screwed.
No, I want you to test. I want
Yeah,
you to
no,
test
I
it.
was gonna test it, but I'm saying, should I just take it and then, because it's real cloudy, just put it in there, the flop in there, get everything to go to the bottom, and then
Well,
revacuum.
you go through those checklists first. Test, circulation, filtration. If all those check out, you might have to open the filter. I don't know, because it was pretty nasty when we might need to clean it.
Yeah.
Open it up, spray the cartridges down.
The baskets were real nasty every time.
Those cartridge filters have a little tiny screen on the top.
Okay.
And that little tiny screen, the pipe that comes up through the middle, it draws in the air. If air gets into that filter, the air gets sucked in and pushed out into the pool, so the filter fills up. Well, if your cartridges are dirty, guess where that water's going to go? It's going to go to the least path of least resistance, right? So now it's not going through your cartridge. It's going through that little screen and back to the pool. Well, it's not filtering it. Okay. Same with a DE filter. Has the same setup where there's a little air pipe in there that sucks the air out of the filter. So, check those three things. If all of those three check out, then if you still have cloudy water, what's happening is that the filter isn't filtering down to what is in the water. Cartridge filter filters, I don't know, 3 microns. Okay, it can filter a blood cell, which is pretty small. But you can have things smaller than that, and it could be dead algae. That's the cloudiness is dead algae, and it can be smaller than what the filter can pick up. So a flock is probably needed.
There's not a lot of debris in there, like just from what keeps flying into the pool from the damn tree. But like when you look at it, it's not like it doesn't look like this. Like it's blue, it's pretty clean looking, but it just can't see the bottom.
Yeah. So if your chemistry is right, the color looks right, you have good circulation, and the pool is cloudy,
I think
look at your filter.
I think because when I did the filter, it pushed air back to the pool. So
Yeah, I mean it has has that air release
well, I
on
did
the
that
top.
too, and it's still sent.
Right, but nobody's doing that every day.
Yeah.
Nobody's going out there. You shouldn't have to.
Did you guys clean the cartridges at